Alright, so let's see if we can double check it. So we found, or I found, and presuming I didn't make any mistakes, I found the shunt total to be 500 ohms. I found R1 to be 285.7 ohms. I found R2 to be 98.92 ohms. And I found R3 to be 115.4 ohms. So how do I double check that and see if I did it right? Well, there's a couple of, basically I can just plug my numbers back into my original voltage equations. So just really quickly, I had my range 1 redraw, which just had my meter and my 3 resistors in it, or my shunt total. Okay, so I've got V meter on this side, and basically, V meter on one side, and I've got R1, R2, R3 on the other side, and I know I've got that 2 milliamps going through here. So if I know my shunt total, which is 500 ohms, that should equal the same voltage on both sides. So let's just see. So I got V meter was found to be 1 volt. Come on, little guy. Okay, so V meter was 1 volt. 500. So let's see. V, got branch 1 and branch 2. Branch 2 is just V meter, so V of branch 1 equals V meter. Okay, so let's see. IS1 times all those resistors, okay, equals V meter. Well, it turns out that's how I found that resistor in the first place, so hopefully this all works out. So 2 milliamps times 500 ohms should equal V meter, so 2 e to the negative third times 500 gets me right back to V meter, which was 1 volt. Okay, so range 1 checks out. Okay, so let's get range 2 and we'll just check it. Okay, range 2. This time I had R1 over here and my meter, and R2 and R3. Okay, remember, and so we had our currents. Okay, so I had I meter, which was 1 milliamp, and I had IS2, which was, what was it? So that would have been 6 milliamps. Okay, so here's the test. Okay, so those voltages must be equal. Okay, so let's get back on some green here. So branch 1, branch 2. If I did these resistors correctly, then my voltage equation must be true. If it's not true, then I made a mistake. So, whoa. Okay, so just to express that, V branch 1 must equal V branch 2, or I've made a mistake. Okay, so basically I've got, let's just get in here like this, IS2, okay, and these equations are going to look really familiar, hopefully. R2 plus R3, okay, it must equal I meter times R1 plus R meter. Okay, so 6 milliamps times the sum of those two, which I can't do in my head, but it's 98.92 plus 115.4 must equal 1 milliamp times 1285 2.86 to round. Okay, remember that from before? I did do that in my head. It was crazy. Okay, so let's bring back the old calculator and see what the calculator has to say. Okay, so on one side I've got 6 milliamps. Okay, so this is a moment of truth. Let's see if it worked. So I've got my 98.92 plus 115.4. Okay, so let's see what that voltage is. Okay, so on that side I've got 1.286 volts. So let's see if it equals. Oh man, it's looking mighty promising. Okay, we're almost home. Okay, so let's just do it. 1 e to the negative third times, remember the mental math here, 1.286. I could almost do this one in my head. Okay, look at that. 1.286 volts. Boom. So that checks. Feeling good. Feeling great. Okay, so range 2 checks. Alright. Okay, so I kind of used up a lot of room here on range 2 check, so let's just see if I can actually get somewhere with this thing. I'll have to find a different program. Okay. Alright, so let's do our range 3 double check. Okay, get back into some blue maybe. Okay, remember your range 3 redraws, R3, R2, R1 meter, and that all by itself. Oh boy, come on. So my actual mouse will make this work a little bit better. No, I don't know if that's better or worse. If you're watching, you're probably getting seasick. Alright, anyway, here we go. Okay, so I did have some current. So I had 13 milliamps coming in, right? IS3, which was 12 milliamps, and then I meter, which is 1 milliamp. Alright, so we'll see if that turns out to be true. And so basically all we're going to do is do our voltage equation, right? This, whoa. Okay, so come on. So branch 1's voltage must equal branch 2's voltage. Okay, so VB1 must equal VB2, or I've messed up. So let's see if that's true. Whoa, hello, it's 5:50 in the morning. Okay, so let's see. IS3 times R3 must equal I meter times R2 plus R1 plus R meter. Okay, let's see if that's true. Okay, so 12 milliamps times what did we find? R3 is 115.4 ohms equals, or better equal, 1 milliamp times those 3 resistors. Getting a little better. Let's see if I can keep that up. 98.92 plus 285.7 plus 1K. Alright, let's see if that all works out. Bring up the old calculator. Okay, so the branch 1's voltage is going to be 12 milliamps times 115.4. If you miss that you fat fingered your calculator, you're gonna have a bad day. 1.385 volts equals, here we go. Let's see if it's gonna work. I'm just gonna plug it in so I can look at what I've done. 1 to the negative third, and I've got 98.92 plus 285.7 plus 1K. Here we go. Oh man, like magic, 1.385 volts. So big smiley face for range 2. It's also going to check out. Whoa. So sorry about that crazy scrolling, but there's basically my final answers. And let's see, it took me just under an hour. I'm going to give my students, I think, a little bit more time for this one, although I was explaining some stuff. Luckily, I didn't make any mistakes. So I'm going to end the video here. Hopefully you can follow along with what I've done and get through this circuit. There are other ways to solve these kinds of circuits, but this is I'm not going to say intuitive way, but basically we're exploring those mathematical relationships, trying to identify them and use them to solve the circuit. So it's like little pieces of more advanced Kirchhoff analysis techniques. So I'm going to end right there and call it good.